Namaskar my dear friends. Let us talk about resistor selection process today. So we'll try to understand what is the best suitable method or how we can select the best suitable resistors for our applications. So as you can see, resistors are basic building block of any circuits, whether it is medical circuit or automotive or industrial circuits, consumer applications, various appliances or home application circuits. Any circuits you take, there will be resistors of various values, whether it is 0 ohm or 1 kilo ohm or 100 kilo ohm or 1 mega ohm, 2.2 mega ohm or something like that. Okay. So as you can see, we have leaded resistors. Earlier it was being very used. These days also these are preferred in higher power resistors. Okay. And where you have big space boards or where you don't have a space constraints, there you want it to be bit sturdy resistor, like a strong resistors, then leaded are preferred. At the same time we have cheap resistors, so we will be basically talking about cheap resistors in this particular session, like thick film resistors or thin film resistors. Okay, so you can see various diagrams are there or various pictures are there of different kinds of resistors, like leaded resistors are there, then chip resistors are there, we have potentiometers, we have trimmers, okay, we have wire wound resistors, we have metal resistors. Okay, so as you can see, we have various kinds of resistors. So let us talk about, I was talking about chip resistor which can be surface mount. We have through hole resistors, that leaded resistors I was talking about. We have potentiometers or trimmer whose values can be varied. Okay, we have some specialized resistors. Okay, in that case you can have a bit higher power with a little different package and all. We have adjustable power resistors as well. We have rotatory potentiometer and rheostats, all those things are there. So general type of resistor that will be used in this particular circuits these days are thick film resistors and thin film resistors. Okay, so thin film resistors are basically used for very accurate application where you need to have like very sturdy resistors, or its value do not change with time at all. Okay, so they are very accurate, however they will be a bit costly. So other than that, if you don't have a requirement of very high accuracy and there should not be a like little bit of change of the resistance values, then thick film resistors can meet your all the requirements. So generally we will be talking about thick film resistors which is abundantly available. Okay, so as we have already seen that we have this is the particular resistor series that is taken from Vijay. So Vijay has like fixed resistors or network and array resistors. Array resistors means in one package you will have various resistors, like 4 5 resistors or 6 resistors will be there in one package. We have thermistors like NTCs and all, we have varistors, we have trimmers, we have rheostat, we have panel potentiometers, like it can be mounted on panels and all, and we have custom resistors as well. So our main aim is to understand the fixed value resistors which can be utilized for various application circuits. So this will look like something like this. It can be coming in different package also and different colors also, but mainly this will be cheap resistors. Okay, so what are the various parameters that we need to look into before selecting a resistor? That's the main understanding. So first of all, we'll talk about some of the manufacturers. Okay, so the parameters could be which are the manufacturers from which we should buy the resistors. So there are various manufacturers these days. If I list out some of them, these manufacturers can be like Vijay. You can see here Vijay is there. Then we have Stackpole, we have KOA, we have Walsin, we have Samsung Electromechanics, we have Bonds, we have Panasonic, we have T, Yagio, Rome. So various different manufacturers are there for the resistors. Okay, now coming to the next parameter, it can be manufacturer part number. So manufacturer part number will depend based on the value of the resistors, and it's different methods of marking the part number. So that will depend based on the value, that based on the part that you have selected. So we'll see this one at last. Now part status. So anyway, if you are going to select a resistor, whatever the resistors that you have selected, it must be meeting the longevity analysis. Like let's say it will remain for around 10 years or something like that. Okay, but these days almost all resistors are there for 10 years 20 years, so that's not a problem. So you need to find a resistor which is quite active. Okay. Next comes to the fact that resistance value. So what is the value of resistor that you want to find out, whether it is 0 ohm or 1 ohm or 10 ohm or 100 ohm or 1 kilo ohm or 2.2 kilo ohm. So various values will be there. So whatever the circuit design that is there with you, whatever the value that you have decided, based on that you can try to find it out. So which value do you need to find? Okay. Next comes to the tolerance. So these days almost 1% resistor values are generally preferred. Okay. If you want, you have lot of like room, then you can go ahead with 5%, but I'll suggest you to go ahead with 1% resistor these days, because these are very standard resistors. Okay. And if you need to have very high accuracy and all, then you can go ahead with 0.1% as well, because this will be used for like a trimmer in the oscillators and all. So there you need very high accuracy, as well as you need to have some current sense resistors. In that case you need to be very accurate. So for that you will go ahead with very good tolerance, that is 0.1% or something. Okay. Coming to the fact that power, so anyway any circuits that you have, let's say you are going to have 1 kilo ohm and the current that is flowing into I in this, so based on the power dissipation across this, you will try to find out what is the power that is going to dissipate across this. Okay, so based on that you will be having a power value, and in that I will suggest you that whatever the power that you have calculated, let's say Px, then the resistor that you are going to select must be uh, close to like 4 times or something, then only it will be better. Okay, so I'll suggest you to try to select a resistor of around 3 to 4 times higher power rating. Okay, and if it is having very high power, let's say 1 watt is the power dissipation across this, then we can go ahead with like 2 watt or 3 watt resistors. But if it is 0.1 watt or something like that, then you must go ahead with 0.4 watt or more than that. Okay, so that's the understanding. So very low power, then you can go ahead with 4 times 5 times of the power rating, and if you have very high power, then 2 times 1.5 times is also suitable. Coming to the fact that composition, so whether it is thick film, THICK, thick film, or thin film. Okay, so if you have very high accuracy requirement like measurement devices, and you don't want the value of the resistor should change with time, let's say after 1 year or something like that, after 1,000 hours and all, then you can go ahead with thin film resistors. Otherwise all the general application, thick film will be much suitable. However thin film will be prone to the moisture, so thick film are very good for that purpose. Okay, some other parameters that we see is features, like we have some moisture resistance resistors, as well as AEC, like Q10 100 ratings, or KAEC Q200 is there. Okay, so all those ratings are available. Sorry, this is not AEQ, this is AEC ratings. Okay, so AEC Q200, AEC Q100. So AEC Q200 is actually used for your resistors. So AEC Q200 is used for your automotive grade resistors. Then the very important parameter that comes up for the resistor is temperature coefficient of resistors. Okay, so it is in the terms of ppm. Let's say plus minus 200 ppm per degree centigrade, or plus minus 100 ppm per degree centigrade. So this value, as it is going to be lower, it is much better. Okay, so as good as like 50 ppm per degree centigrade, or plus minus 25 ppm per degree centigrade. So for general application, it is suggested that you can try to use plus minus 100 ppm per degree centigrade, and if you have to have very high accuracy resistors, then you can go ahead with plus minus 25 ppm as well. Okay, so it means like the value of the resistor that will vary based on the temperature range is 100 parts per million. Okay, that's the meaning. Now coming to the fact that other one, which is operating temperature range. So operating temperature range, generally all the resistors are coming up with minus 55 degree centigrade to, or minus 40 degree centigrade to 155 degree centigrade. Okay, so just try to meet this application. If the value of the temperature is not meeting the resistor uh, part, then you need to understand this, like the temperature range must be beyond your working. Okay. Now the very important part that comes up is package. So what is the package that you are going to select for your resistor? Whether it can be 0402, even it is lower package, these days it is coming is 0201. Okay, so the lowest package you can have is like 0201 generally. So 0402 or 0603 is more a standard package, which is little bit higher. 0805, we will see the what is the dimension and everything of each one of them. Then 1206, 1210, then like so many other resistors are also there. So as you can see, as the package size increases, their power rating also increases. So power dissipation capability or power rating like capability will increase based on the package. So if you need to have little bit higher power ratings, you need to find out higher package size. Similar to that, each one of them will be having one dimension, like we will be seeing one chart. In that we will be mentioning for each code, these are called as package code. Okay, so in this, each one of these resistors, they have a code and their particular dimension will be in terms of length, width and height. So we'll try to understand our length, width and thickness. Okay, so height is sometimes called as thickness as well. Okay, so this is the way we will try to understand what is the length, width and height of each one of them. Now coming to the fact that rating, so sometimes I just now I mentioned that AEC Q200 ratings or some other standard rating is there for military application or space applications. So and this is AEC rating is for automotive applications. So if you need automotive resistors, then you must have requirement of AEC Q200. Similar to that ROHS, so any component that you are trying to find out these days, any electronics component on your PCB must be ROHS compliant, otherwise you won't be satisfying the IEC criteria or something like that. So if you have to have CE standards or something like that, you must select a resistors of or any component, any electronics component with ROHS compliant. So this is what all the informations about the like different parameters that you need to keep in mind before selecting a resistors. Any resistors that you have in your mind, try to have those informations in your list, then only you try to go ahead with finding a resistors. Now let us try to understand with some of the values directly. So what we have done is we have taken one of the resistor data sheet. Okay, and in this we can see that we have in imperial size, that is package size. So package size you can see we have 0402. So let us concentrate one by one. 0402, 0603, 0805, 1206, 1210, 1218 is also there, 2010 is there and 22512 is there. Okay, so in my opinion up to 1206 you can always concentrate. Next you can directly go ahead with like 1210 and 2512. Okay, you don't have to concentrate on like 1218 and 2010. If it is very specific, then you can look into them as well, but this 2512 will be very standard compared to these two. Okay, so that's the package size that we have seen. Now you can see resistance ranges. So any value that you want to find from 0402 to up to 1206, we have the value available from 1 ohm to 10 mega ohm. Okay, 10 mega ohm means 10 to the power 6 ohm, that's the meaning. Okay, and we have jumper as well. So 0 ohm resistor will be called as jumper. So basically this resistor will be having 0 ohm. It means the resistance offered by this particular resistance is almost 0 ohm, but it is never 0. It will be in terms of, let's say, 15 milliohms or something like that. Okay, so that will be mentioned in the data sheet. Now as I was talking about resistance tolerance, so you can see resistance tolerance is having plus minus 5% and plus minus 1% for all of these values. Similar to that we have temperature coefficient. Okay, so temperature coefficient was plus minus 200 ppm per Kelvin. Here it is per degree centigrade or per Kelvin, both will be almost same, and 100 plus minus 100 ppm. So plus minus 100 will be better than plus minus 200 ppm. Okay, that's the understanding. Then as you see my size is increasing, is increasing, the power is also increasing. Okay, so corresponding to each one of them, let us say we have power rated as 0.06 0.063 watt. It means it is 1 by 16 watt. Okay, and this is 1 by 10 watt. So as you can see, 0603 is 1 by 10 watt, and 0805 is 1 by 8 watt, okay, and then 1206 is 1 by 4 watt, okay, quarter watt, and 1210 is 1 by how much, it is 0.5 watt, so 1 by 2 watt, okay. So that's the understanding. If you go ahead with a 2512, then it is 1 watt. So that's the understanding. There is voltage rating also for the resistor, like up to what voltage, like maximum it can withstand. So the voltage must be applied 50 volt for 0402, 75 volt for 0603. So one more thing you have to understand very clearly, that let's say this is the particular resistor that I have taken from Vijay, okay, data sheet. So this series CRCW 0603 or 0603 package is having a capability of 75 volt rating. The same resistor 0603 package from other manufacturer may have the operating voltage range little different. It can be 100 volt itself here itself, okay. So that's the understanding, but you need to keep all these things in mind before selecting a resistors, okay. Now similar to that, you can see other values also, like for other resistors, as you go on increasing the package size, their power rating as well as their voltage rating both are higher. That's the main understanding. Now coming to the fact that what is the derating curve. So if you see power derate, this is the power derating curve of the resistors, okay. So we have, let us say, 0603, this is the this color, okay. So this color is going to be this one, okay. So this color, as you can see, we have the power rating of whatever the power rating is there right now. So it is going to be minus 55 degree centigrade to up to 70 degree centigrade. It is almost, like a constant. It is not going down. But as the temperature increases more than 70 degree, the value decreases, okay. It means the power capability of the resistor decreases based on the temperature increase. So as we see a little bit higher one, let's say here it is very clear. So 1218 package or 2512 package, this is the green one. So if you see, it is 1 watt rating up to 70 degree centigrade, and as your circuit temperature is going to increase more than 70 degree centigrade, the power rating goes down. So let us say at 70 degree, then this is 100 degree, right? So it will be around how much, 75, 80, 85, 90, 95. So at 90 degree centigrade, it is going to close to 0.75 watt or something. So from 1 watt, the value has decreased to 0.75 watts. That's the understanding we have to have, okay. Now the last part was, we must understand what is the package size of each one of them, okay. So if we see the dimension of each one of them, let us say we have to have 0402, 0603, 0805, 1206, okay. So each one of them are having sizes as well. So length, width and height. So this is the length that is there, that this is the resistor, okay. So if I mention here this length, this is called length, and this is called width of the resistor, and this is the height of the resistor. So this is the three meanings, okay. And then T1 is actually the thickness of this pad, okay, that will be there, okay. So this is T1, and T2 is what is the understanding this side, okay. Like what if you see this way, you can see very easily see, okay. And this is the pad size, so this will be in the next page as well. So we'll try to understand what is the understanding of this, but each one of the packages. So 0402, you can see it is 1 mm cross 0.5 mm cross 0.35 mm, okay. So if we take 0402, it is going to be 1 cross 0.5 cross 0.35 mm, okay. Each one of them are in mm. Similar to that, 0603, it is going to be 1.55 cross 0.85 cross 0.45, okay. So as you can see, this is taken from Vijay datasheet. However, other manufacturers resistors with same code like 0603 will be having package size almost same, the dimension will be almost same. It may vary 0.05 mm up or down, like it can be 1.6 mm or it can be 1.5 mm, okay. It will not vary much. However, these are standard packages, and it will all match. Any manufacturer 0603 package will be almost same or almost equivalent to each other. Similar to that, if you see the pad size, then you can have a look in the next page. So you can see 0402 for reflow soldering, this is not recommended web soldering. Okay, so reflow soldering, what is the G, that is distance between the pad, then what is the total distance, that is Z, and then what is the thickness of each pad, that is Y, and what is the width of each pad, that is X. So all these parameters are given here, so that you don't have to worry about. But we have to much understand that what is the particular, like package dimension for each one of them. So as you can see, for 0603 it is 1.55 mm length, and it is almost double, so that is 1206, it is double of 0603. Okay, so hope you have now very good understanding about the resistors and their different parameters that we need to look into before selecting particular resistors. So like what should be the package, what is the power rating, and what is the temperature range, and for what application it is going to be used also, whether it is going to be used only in industrial application or consumer application, or it is going to be used in automotive or even military application or space application. So based on the applications also, resistors are coming with much more moisture resistance, or like different kinds of resistor which will be meeting your requirement of temperature, sturdiness and everything. So we will see how to read the data sheet of a particular resistor as well, like how to find out the particular part number of a resistor from the data sheet, and what are the uh, different parameters and different information that is mentioned in the data sheet of a resistor from different manufacturers in our next session. And if you do have any questions regarding the selection process of a resistor for your particular applications, or what should be the value, how to calculate a value of power of the resistor requirement in a circuit also, you can put down your questions in the comment box and we shall be able to answer you out. Thank you so much.